Welcome to this channel by the name of Royal Mentor. Today in this video we are going to study about atomic radius. In the last video we had already studied the introduction of periodic table. Today in this video we will study physical and atomic property of three elements. First of all, what is the difference between physical and atomic property? First of all, we have to know that what is the difference between physical and atomic property. Okay, so individual atom property is called atomic property. Electronegativity, for example, electronegativity, ionization energy, atomic radius and electron affinity, these all are considered as atomic properties. Okay, now what is physical property? Whenever different atom of any element combine with each other, some property are there in the combined form of atom. So the study of such properties which are present in the combined form of atom is called physical property. For example, what are the examples of physical property? Melting point, boiling point, conductivity. These all are the properties of atoms when they are in the combined form, not in the isolated form. Okay, so these physical properties in the combined form of atom depend upon strength of attractive force which are present. This attractive force is present between the atoms. Attractive force between the atom may be in the form of covalent bond, metallic bond, Vander Waals forces. So now I hope you understand the difference between atomic property and physical property. Okay, in physical and atomic property, the first property is atomic radius. Atomic radius is an atomic property. We will study that what is atomic radius and what is trend of atomic radius along the period, okay, when we move from left to right in periodic table. So to understand atomic radius, consider this given diagram. This is the atom having nucleus and one shell. This purple line from center of the nucleus to the valence shell represent atomic radius of this atom. Okay, so atomic radius is the distance from center of nucleus to valence electron. Here you guys can see in this definition of atomic radius, it is generally defined as the distance between the center of the nucleus and the outermost shell of the atom. Okay, so it was all about of atomic radius and atomic radius definition. Now the question arises that how can we measure atomic radius of an atom? Atomic radii are determined and find by what? By X-ray diffraction, electron diffraction, NMR spectroscopy. Okay, so here you guys can see the second point, measurement. So atomic radii are determined by X-ray diffraction, electron diffraction and NMR spectroscopy. Okay, so now we will study trend of atomic radius across period 3 element of periodic table. When we move in the period from left to right, atomic radius decreases. This diagram shows that atomic radius decreases as we move from left to right, from sodium toward chlorine. So atomic radius decreases due to the addition of electron in the valence shell as the number of electron increases in the outermost shell as we move along the period from left to right. On the other hand, number of proton also increases in the nucleus of an atom. Consequently, electrons are more attracted toward the nucleus and pull the shell nearer to the nucleus. Thus atomic radius decreases. Okay, so the point the above diagram show, I have already written this explanation in written form on the screen. You guys can see the above diagram show that atomic radius decreases from sodium to argon. The atomic radius decreases in the period from left to right due to addition of electron in the same shell. As the number of electron increases, the number of proton also increases, which increase the nuclear pull on the electron and pull electrons nearer to the nucleus, and atomic radius decreases. Now we are going to study different type of classification of atomic radius. Classification. So atomic radii are subdivided into covalent radii, metallic radii, Vander Waals radii. Okay, now what is covalent radius? How can we determine covalent radius? Whenever there is a single bond length between two identical atoms and we find the length of same bond, okay, which is present between two identical atoms, now we will divide this bond length by 2. The half bond length is the atomic radius of one atom and the next half bond length is the atomic radius of another atom. This is how we calculate the covalent radius of an atom. We cannot calculate, okay, we cannot calculate radius of single atom, but we can calculate radius of an atom when they are in the bonded form, not in the isolated form. So here you guys can see I have written the definition, the one half of the distance between the nuclei of two similar or two identical atoms containing a single covalent bond. Okay, here I have given some examples which will help you to understand covalent radius more clearly. bond length between two hydrogen atoms is 74 picometer. Here you guys can see bond length between two hydrogen atoms is 74 picometer. Now we will divide this 74 picometer by 2. Okay, in order to have a covalent radius of two individual atoms, covalent radius of single hydrogen atom is 37 picometer. Bond length between two bonded carbon atom is 154 picometer. Okay guys, in order to find covalent radius of individual atom, we will divide 154 by 2. So 77 picometer is the covalent radius of single carbon atom. Metal atoms do not form covalent bond between themselves. So now how can we express metallic radius between the metal atoms? Metallic radius can be explained in such a way that inside metallic lattice we have close metal atoms, which are also called adjacent atoms. We have some distance between the two close atom or adjacent atom. This distance between the two close or adjacent atoms should be should be determined, and this distance should be divided by 2 to get metallic radius of single atom. So here you guys can see metallic radius is defined as one of the half distance between nuclei of two metal atoms in metallic lattice. So metallic radius of sodium is 191 picometer. This was all about metallic radius. So now what is Vander Waals radius? Now we have some atoms, okay, which neither can form covalent bond nor metallic bond. Such atoms are bounded to each other through Vander Waals forces, and we represent their atomic radius in terms of Vander Waals radius. What is Vander Waals radius? It is half of the distance between nuclei of two non-bonded atoms. It means bond is not formed between these atoms, but we compressed these atoms as much as possible. Further, these atoms cannot be compressed anymore. So at this time, we will find the distance between two nuclei of the two same atoms, and we will divide the intermolecular distance by 2 to have Vander Waals radius of the atoms. Vander Waals radius of argon is 1.91 angstrom. Okay, here in diagram you guys can see two argon atoms. Okay, they are in bonded form with each other. The distance between two argon nuclei is the Vander Waals distance. Okay, and the value of Vander Waals distance is 3.38 angstrom. In order to find Vander Waals radius, Vander Waals distance should be divided by 2. Here I have divided 3.82 angstrom divided by 2. The result value is what? 1.91 angstrom. So 1.91 angstrom is the Vander Waals radius of argon. Here you guys can see in this diagram that sodium, magnesium, aluminium form metallic bond. So this is why these three atoms have metallic radius. Okay, silicon, phosphorus, sulfur and chlorine form covalent bond, and due to which these 4 atoms form covalent radius. Argon form Vander Waals bond. Okay, so argon radius is larger as compared to the other elements in the periodic table. So wish you best of luck. See you in the next video. Goodbye.